Yeah, I got it. I understand. My parents were the same way. My parents only let me cut the day after senior trip because we got back so late. And I had to convince them to let me cut school the day before winter break, that half day, my senior year only. Okay. Anyway. So we have our equation. We have our Ka. We have Pk. How can we find Ka? 10 to the negative. So this is going to be 10 to the negative 9.23. And what does this become? Which, by the way, because this K is really, really small, this is a very, very weak acid. Very weak acid. Okay. What's next? Find the pH. Okay, so in order to find pH, we need to know the concentration of H+. Well, or the concentration of the hydronium ions. They mean the same thing. Well, I know the molarity of this, right? It's 0.25, but because this is a weak acid, if this is 0.25, does that mean this is 0.25? No. So the question is, how can we figure that out? Well, we can write an ice chart. But these ice problems, they all look the same. So I'm not going to actually write a full one out, but hear me out here. This is the only thing you start with, and H2O is irrelevant because it's a liquid. What do these two things have to start off as? 0. They both have to go up by the same amount. Let's just call it X. At equilibrium, these are both going to be, they're adding, so they're both going to be just X. This is some value, whatever it might be, number sign. K is really, really, you just showed it to me, it's really, really, so what rule kicks into effect? Which means at equilibrium, this number is the same. From this, I can now do this. I can say that the equilibrium, Ka, at equilibrium is equal to our products, which is H2BO3 minus times the hydronium ion up top. And on the bottom, the only product that's worthwhile is the initial acid. The H2O is irrelevant. This formula in orange is on your equation sheet. This is the generic equilibrium formula for all acids. It's the acid ion, so like the H plus or the H3O plus. It's the conjugate base, that's the A minus, over the acid. Okay, now, Ben, your question from before about the KB problem, right? Methylamine is a base, so it would be KB equals, now it's the exact different perspective. So on the bottom isn't the initial concentration of the acid, it's the initial concentration of the base. Up top, What's H plus's antithesis if it's a base? Not H plus, but OH minus. And then the antithesis of A minus is B plus. It's opposite. So here's the big difference. If you're a base, you are automatically producing what? Hydroxide ions. And because you're going to be producing those hydroxide ions, you are going to be a pH over 7. So even if your Kb value is super small, we don't turn it into an acid because as a base, it produces OH molecules. So that's why if we did this problem, we would be finding first not pH. For this one, we first have to find the P. And then when you find the pH, it mathematically will have to be above 7. Even though these two Kas are small, because they are Kas, we are finding H3O plus, which means we can directly find pH, and no matter what, they're going to be less than 7. They might be really close to 7, but they're still going to be less than 7. So because it's a base, even if it's the crappiest base in the world, it's still going to have a pH above 7. And if it's the weakest acid in the world, it'll still have a pH of under 7. Even if it's like 6.9, the other one's 7.1. There's still ones below 7, ones above 7. So that's why we don't need to worry about that other part. Okay. All right, well, let's think. If I want to find pH, I need to know this. Well, guys, we know everything. Chelsea. Again, what was the Ka value? Because I erased it. What would we get?
5.9 times 10.
Got it. What is always true about the value of this thing and this thing? They have to be the same. Well, if I don't know this and I don't know that, I'm just going to call them both x, and there's two of them, so it's x squared. And on the bottom, it's just the concentration. What was the concentration of the boric acid initially? 0.125. So, to solve for x, we multiply and then take the square root. So we do some math. All right, 5.9 times 10 to the negative 10th times 0.125 squared. Oh, nope, sorry. That's not right. I am getting for x 8.6 times 10 to the negative 6. So far, so good? Well, that's not the answer, because I don't want the concentration, I want the pH. So now we're going to take the negative log of this. The negative log of the hydronium ion concentration. And you get, I got 5.6. Oh, I can't read. 5.06. 5.1. Sorry. There you go. Notice, guys, look. This is a really high, like, this is a really small Ka value. So same idea, you're talking about that ammonia thing. Wouldn't the other thing be, right? But even though It's a really weak acid. Its pH was still less than 7. So that's how it still kicks in. So let's think. We rewrote the equation. We found the Ka from pK by doing 10 to the negative pK. That gave us the Ka. We set up our equilibrium expression. It always works out to the same general format. We found the concentration of the hydronium ion, found the pH. Last part of the question is find the percent ionization. So forget about chemistry for a second. Percents is just an individual over the total. So if you want to find out the percent that something ionized, you need an ion over the total. Does it technically matter which ion you use? No, because these show up at the same rate. So if I wanted to find the percent ionization, I know my ion concentration is this. And I know my initial concentration is 0.125. And because it's a percent, after I divide, I just have to multiply it by 100. And you're going to get a very small percentage. I got 0.0069%. Or 6.88 times 10 to the negative third percent. Which means out of every 10,000 boric acid molecules, only 69 of them will ionize. The rest of them will just stay as boric acid. That is an entire weak acid question. That is a whole weak acid problem. If it was a weak base, it'd be the same thing, except instead of Ka, it would be Kb. And then the one thing you got to watch out for is you don't first find pH. You technically first find P, and then you have to go backwards to find pH. But that's it. Let's do one more together, and then we'll do some homework and practice, and that's that. All right. And tomorrow is going to be very similar because I just did miss class. Like, this is not something to, even with the video, obviously not something to just gloss over. Too big of a topic. All right, last one. Okay, ooh, this is a good one. Because this is the one where it's like, man, I'm lost in the woods. A 0.025 molar solution of a weak acid, HA, is 30% ionized. What is the pH? What is the Ka? What is the pKa? Now, guys, for this one, I promise you, we got to go in order. So, I may know where to start. Or is it easier to start where we end up? Okay, so I know 30% what then? 30% has been, so if I know 30% has been ionized, I know that ionization is H plus over HA times 100, in this case, equals 30. Well, do we know, right, in order to find pH, I need to find the concentration of what route doesn't work for this particular problem at all? How else can you find pH? You could find the P. Why doesn't that apply? This probably, you can't do it. We don't have anything that's basic here. So like there's no way to get it. So we can't go that route. This is the only route to go. That's okay. Well, we need this. In order to find this, we need to know HA. Do we know the concentration of our acid? Yeah, it's 0.025. 0.025. So h plus over 0.025. Now, I'm going to do some quick math here. If I bring the 100 to the other side, 30 divided by 100 is 0.3. How can I bring the 0.025 to the other side then? Multiply it. And if you bring it over, you're going to end up with 0.0075 equals the concentration of H plus. Hey, if I know the concentration of H plus, can I find the pH? Yeah, because I can just take the negative log. So, the negative log of 0.0075. This is why we don't have nice things, Benjamin. All right, and then the negative log of 0.0075 is, Chelsea, what do you got? 2.12. Yes. All right. All right, next one. How do you find Ka? Well, the easiest way to find it is to know the pKa. But unfortunately, that's the next question, so that's not going to work. What equation can we use to solve for Ka? We just did it. Yeah, so we can say, right, Ka for any acid is H plus A minus over HA. Well, let's think about this. Ka, we know the bottom is 0.0025, and we said H plus was 0.00, oh, I'm sorry, this is wrong. This is 0.025, and this is 0.20, my bad. So we found the H plus concentration. We did the percent ionization formula. What's A minus going to be? Which is it the same? Is it the same as top or the same as the bottom? Yeah, because when it ionizes, it makes equal ions of H plus and A minus. So this is also 0.0075. And now we can just do some quick math. We multiply the top two numbers together. We divide by the bottom. Then we're getting 2.25 times 10 to the negative third. And then last but not least, in chemistry, P stands for negative log, so the pKa is the negative log of Ka, so the negative log of 2.25 times 10 to the negative third. .65. Nice. All right, let's end with this.